So using trigonometric ratios, we're going to be finding sine, cosine, and tangent. Start by knowing which side is the adjacent, which side is the opposite in our triangle. Okay, so we're going to start by identifying the angle. We'll always do this from one of the two acute angles of a right triangle. We never use the 90. So identify which angle we're working from, and that angle has two sides. One of them already is named the hypotenuse. The other one we'll call the adjacent, and the one across from that is the opposite. So we just went through these. My class has been working on the next few. So we're using angle A for all these. All right, angle A is the angle that we're working from. And that means on this one, these two, that's not a good color, is it? This is the hypotenuse. This is the adjacent. So that means this must be the opposite. It's crucial to be able to correctly identify these because otherwise you can get every single problem wrong when you're trying to work with sine, cosine, and tangent. For the next one, here are the two sides of my angle. This one's already called the hypotenuse. This one is the adjacent then. And that means the opposite is over here. Next up, two sides of the angle. Here's my hypotenuse. Here is my adjacent. The two sides of your angle are always the hypotenuse and the adjacent. So here is the opposite. It's across the triangle from your angle. Next, we have two sides of angle A. This is the hypotenuse. This is the adjacent. And this is the opposite. I see some people making corrections. Make sure you're checking as I'm doing this. And last but not least, angle A over here has these two sides. One of them is already called the hypotenuse. The other one we name the adjacent. And we almost always write it, adjacent. We almost always write it with the three letters. We almost always abbreviate adjacent, ADJ, hypotenuse, HYP, etc. And there's my opposite side. Okay, so you have to be able to identify, first of all, which angle you're working from. Like, which angle am I looking at this right triangle from? And it's always going to be one of the two acute angles, not the right angle. And then identify the three sides as hypotenuse, adjacent, or opposite based on which angle you're using. All right, so here we go. Sine, cosine, and tangent that you've heard about all your life, they're just ratios. They're names for ratios. Okay, first of all, do not pronounce this sin because it's just short for sine, and we usually don't say sin or sine. Well, if you say sine, you said it, but we always say the name of it. And the same thing here. This is the cosine. It's just an abbreviation for the cosine. And this is abbreviation for the tangent. So these are the three basic trigonometric ratios. A lot gets built on these. Like all of trigonometry, which is basically what you're going to be doing in pre-calc, is based on these. All right? There are three other trig functions that you'll get into later in life. And you'll do a lot more things with this. What we're doing is basic right triangle trig. It's the foundation of all of that. All right, so the sine is just a name for the ratio of the opposite side to the hypotenuse. Cosine is just a name for the ratio of the adjacent to the hypotenuse. Tangent is just a name for the ratio of the opposite to the adjacent. Okay, what is this? This is theta. That's a Greek letter. We very often use it as a variable when we're talking about an angle measure. So that just stands for the measure of the angle. It's like saying sine of my angle, cosine of my angle. So you have to know which angle you're looking at it from. Okay? So for instance, down here, they called it angle A instead of calling it theta. But that's just the angle. You don't ever see sine by itself or cosine by itself or tangent by itself. It's always tangent of something, sine of something, cosine of something, and that's an angle. Because you have to know which angle am I looking at this right triangle from. Okay, so first off, it says, example 1, using the given triangle, find the following. Let's move it back down so we can see. Again, that says theta. First off, we don't know all three sides. What's the third side of this right triangle going to be? not going to be 8. Let me caution you against something that may have just happened. Usually when we learn this, we've just come out of doing special right triangles. You have to remember that special right triangles are special. They're not every right triangle. You don't see 45-45 here, or you don't see 30-60 here. This is not a special right triangle. This is just a generic right triangle. Okay? But it happens to have two sides that are 8 and 10, and those go with the Pythagorean triple 6, 8, 10. Remember we said that 3, 4, 5 was a common Pythagorean triple, and if you multiply all of these by 2, you get 6, 8, 10. So this side is 6. Do you have to remember that? No. You can do Pythagorean theorem. X squared plus 8 squared equals 10 squared. That's 100. Minus 64 is going to give you 36, and the square root of 36 is 6. So you can use the Pythagorean theorem to find your missing side of your triangle. Okay? You don't have to remember those Pythagorean triples. But a lot of times they use the Pythagorean triples to try and make it a little easier on you, so it's a little nice if you do know them. All right, so sine of A. We're looking at everything from the perspective of angle A. So that means hypotenuse is hypotenuse. This would be the adjacent for angle A. That makes this the opposite for angle A. So sine of A is opposite over hypotenuse. So I put the opposite over the hypotenuse, 6 over 10. If I can reduce, I do. And so that's why we get 3 over 5. So the sine is just the name of the ratio of the opposite side over the hypotenuse. It would always have the same ratio because we're talking about the same angles, so they'd be similar triangles. Cosine of angle A, adjacent over hypotenuse. So that would be 8 over 10, and then I reduce. Tangent of angle A, opposite over adjacent, so 6 over 8, and then I reduce. Okay? Next up, we're looking at everything from the perspective of the other angle. So now we're going to do everything from the sine of angle, or everything, from angle B. Question? Okay. Since I wrote on this one, I'm just going to redraw so I can label it for angle B. Here's A, here's B, 10, 6, 8. For angle B, 10 is always the hypotenuse, but this would be the adjacent. 6 would be the adjacent instead of 8. And 8 would be the opposite. So when you go from looking at the triangle from one of your acute angles to the other, if we move from looking at it from A to looking at it from B, the opposite and the adjacent trade places. What used to be opposite is now adjacent. What used to be adjacent is now opposite. Right? That's going to come back. If the opposite and the adjacent trade places, there's a special relationship between the sines and cosines. Okay? So we'll come back to that. So B, sine of B is opposite over hypotenuse, so 8 over 10, which is 4/5. Cosine of angle B is adjacent over hypotenuse, so 6 over 10, which reduces to 3/5. And tangent of angle B is opposite over adjacent, so that's 8 over 6, which reduces to 4/3. So here's the patterns I want you to notice here. Since the opposite and the adjacent just trade places, and sine is based on the opposite, and cosine is based on the adjacent, but they're both over the hypotenuse, when you go from one acute angle to the other, the sine of one is the same value as the cosine of the other. Okay? The sine of angle A would be the same as the cosine of angle B. And that happens here too. The sine of B is the same as the cosine of A. What happens to the tangent? Yeah, it flips over. It's the reciprocal. The tangent of one of them is the reciprocal of the tangent of the other one. But this is a relationship that you get asked about a lot, is the sine of one of your acute angles is the cosine of the other one, and vice versa. All right, questions about that? We're going to look at that in a slightly different way in a second too. Example 1. In triangle ABC, angle C is 90, A is 3, and B is 4. Well, that's a Pythagorean triple, so what's C? 5, good. All right, find the length of the hypotenuse. We just did. Okay? The values of the sine of A, cosine of A, and tangent of A. So sine of A is opposite over hypotenuse, which is from A, the opposite is 3, the hypotenuse is 5, so 3/5. And if it's easier for you, you can label the sides every time. I could do it real quick in pencil. This is the hypotenuse. That doesn't need to be in pencil, it's always the hypotenuse. This is the adjacent, and that's the opposite. That's all for A, okay? So the cosine of A is adjacent over hypotenuse, which is 4 over 5. And we don't need to reduce because that's already reduced. The tangent of A is the opposite over the adjacent, which is 3 over 4. You notice we're getting the same numbers, right? It's because it's the same Pythagorean triple, basically. All right, then we go to B. So if we're going to look at things from the standpoint of B, opposite and adjacent will change. So this would be the two sides of B, or hypotenuse and adjacent. So this is the adjacent. I have trouble writing adjacent, sorry. And this is the opposite. So sine of B, opposite over hypotenuse, cosine of B, adjacent over hypotenuse, tan of B, opposite over adjacent. If you're watching the video, pause the video for a second and try that. Okay, so this is what you get. And you would get the same thing if you went through and did opposite over hypotenuse carefully, or if you remembered that the sine of B is the same as the cosine of A, and the cosine of B is the same as the sine of A. And then the tangents are just reciprocals of each other, because opposite over adjacent here, that used to be the adjacent, and this used to be the opposite. So it's like flipping it over. Okay? Let's look at example 2. In triangle ABC, C is a 90-degree angle, A is 4, C is 6. Find the length of the other leg. I'm not sure. Let's see what we get here in terms of whether we want to use exact form or decimal. But length of the other leg, Pythagorean theorem, we're calling that B. B squared plus 4 squared equals 6 squared. B squared plus 16 equals 36. Oh, it's going to be a good radical. I should have thought ahead. When I take the square root of both sides, I get square root of 20, which reduces to 2 root 5. So I'm going to use that. I'm going to leave it as the simplified radical form, which is 2 root 5. Okay, so there's A, or B. I'm at part A. We've done part A. Now I need to do the values of sine, cosine, and tangent for angle A, and then come back and do them for angle B. All right. So again, hit pause here if you're watching the video. Otherwise, I'm going to hit pause, and we're going to all do it and come back together. Okay, if you haven't already paused, do it quick because I'm about to show you the answers. Here we go. Here's what I got. Questions on anything I got? Any that you want me to talk through how I got it? If you are using a multivariable calculator, which looks like this, the radical calculations are super simple, especially if you're in math print mode. Go to mode at the top and then math print. It does radicals for you basically. So like here, 4 divided by, and I would put this in parentheses, 2 root 5. It's going to tell me that that's 2 root 5 over 5. Now, I actually did it the old-fashioned way, which is by hand, which looks like this. You cannot leave radicals in your denominator. So if you get a radical in your denominator, you multiply by that radical over itself. And on top, that gives me 4 root 5. And the whole point of doing this is that square root of 5 times square root of 5 is just 5. So this gives me 2 times 5 in the denominator. Okay, so that's 10. And then the 4 and the 10 are both outside of the radical, so those can simplify. We don't multiply or divide numbers that are under a radical with numbers that are outside. These are both outside. So I can do that division and get 2/5 instead of 4/10. And then square root of 5 is still there. Now, interesting thing about flipping over tangent, if you had to rationalize a fraction and then you're about to flip it over, go back to the irrational form because that makes it easier. In other words, I went back to this one and I said, this is what I'm going to flip over, because then the radical's on top. And then I just simplified 2 over 4 as 1 over 2. And that's how I got this right here. Questions there? Anything I can help with? Okay, so remember, sine, cosine, tangent, they are names for ratios. Now, on the next page, there's just more practice like that. Okay? You can pause it and try it. But down here, I want to point out this is different. This says use a calculator to evaluate sine, cosine, and tangent when the angle is known. What we were doing was we were doing the ratio. We were setting up the ratio, setting up one number over another when we didn't know the angle. We didn't need to know the angle because we knew all the sides. So if you know all the sides, or can find all the sides, that's when you're setting up the ratio just by putting one side over another. Notice we don't know any of the angles. Okay? I'm kind of going into this in detail just because people tend to start getting confused about when do I set it up as a ratio and when do I type it in my calculator. Everything we've just been doing, you don't have to type anything in your calculator. You're putting one number over another number and then simplifying. If they give you the actual angle, though, that's when your calculator tells you what the ratio is. You can't tell what the ratio is because you don't have any side lengths here. But the calculator will tell you. So on your calculator, you'll just type sine of 23 degrees. Depending on what kind of calculator you're in, you want to make sure you're in degrees. Scientific calculators, like the one I'm using, default to degrees. But graphing calculators don't always. So if you're using a graphing calculator, make sure you check the mode and make sure it's not in radians, which is RAD. So here I just type that, and I'm going to go to the hundredths place, so it's 0.39. So this page right here that I'm working on right now, for my students, this is part 1 of your homework. Okay? If you are watching this video later, because I'm going to post this for you guys, or on YouTube, feel free to do this whole page and then come back, because I'm going to do the key next and let you check your answers. For my students, part 2 of your homework is a couple of like Kahoot or quizzes. Practice setting these up. Practice setting up your ratios. Okay? And that's all going to be on Google Classroom. Okay, so if you have not yet tried these 3 problems, go ahead and try them. Hit pause if you need to. And then let me give you the answers. Check your work. Okay, next up, I'm going on to the next set of problems. I will come back and work those, but if you have not tried these, if you want to jump to that you'll have to scoot ahead in the video. But if you were satisfied with your answers there, I think you basically got that, go ahead and try these. Hit pause. And then here are your answers. And finally, we get to the ones where it says the angle is known. We didn't know what the angle was on all